Hi everyone. Today we're going to do the last lesson in our probability unit, which is decision making. So we're going to take all that we've learned about probability so far and apply it to real world situations to make decisions based on what the probability tells us. So our friend offers to play the following game with you. If the product of the roll of two dice is 10 or less, I win. If not, you win. So let's see, what percent of the time do you expect to win? Is the game fair, or is someone more likely to win than another? So we've tried this out. Hopefully we remember that product means a multiplication problem. So we take the two dice, we multiply what's on the dice, and we'll see what happens. So we win if it's 11 or higher. So we need to think of all of the combinations that have a product of 11 or higher. Now we can never get 11. 11 is a prime number. There's no two numbers that are going to multiply to 11 besides 11 and 1. But if it's 12 or it's 14 or any other numbers that we can get, and we also can't get 14. So there's 17 different combinations, and I listed them here, that we win. That means my friend wins 19 ways. So this is not fair. Okay, so this is not a game where I would play it and be happy because someone would win more than I would. If it was 18 and 18, then it would be fair. 18 chances for me to win, 18 chances for my friend, but this game, not fair. So today we're going to take expected value and probability, and once again, we're going to make decisions. We're going to deal with real world situations. So let's explore a little bit. Peyton has decided that he and Elias are going to play a game. Elias is going to pick a card out of the hat. If the card is greater than 2, he gets 3 points. Otherwise, he loses 2 points. Is this a fair game? Write down what you think. Is the game fair? What makes it fair? What makes it not fair? So I want to look at this through the lens of an expected value. Is he expected to win points, lose points, or have the expected value be 0? So he loses 2 points, or he wins 3 points. So I write out the probabilities, and then I know, I write out the events and then the probability. So the probability of winning 3 points is 1/3. The probability of losing 2, -2, is 2/3. When I find the expected value, Elias's expected value is negative, which means if he plays this game a lot of times, he should expect to lose. Meaning it's not a fair game. Okay, the game is only fair if we expect to win and lose the same amount of coins or points or money. If the expected value is 0, it's fair. If it's not 0, it's not fair. Sometimes it's in our favor, sometimes it's in someone else's favor. So, there's an infinite amount of ways to make this game fair. I want you to create one of them. Create a point system or any system you want, which makes these 3 cards be a fair game. One example I came up with was he loses 2 points if the card's a 1 or a 2, and he wins 4 points if the card's a 3. That way, my expected value is 0, and then the game is now fair. There's an infinite amount of ways you could have done this. So as long as the expected value of your game is 0, it's fair to both sides. Now today we're going to use probability to make decisions. We can use simple probability, we can use expected value, we can use probability distributions, binomial distributions, anything we've learned, we can take, analyze the probability and determine, is it a good idea or a bad idea? Do I make money or do I not make money? I can compare several expected values of several situations and pick the best option. I can make graphs and tables and figure out what is in our best interest. And businesses do this all of the time. So if a game is fair, the expected value is 0. If it's not fair, we need to figure out, is it in our favor or not in our favor? So we're going to play a game with rolling a die. If a 4 or 5 comes up, you win $4. Otherwise, you lose $2. I want to know the expected value, and is this game fair? So pause the video, test it out, see what you get. Now let's take a look, see what we did. So you can have 2 outcomes. You can win or lose. So this game, only 2 outcomes. You win $4, and the other outcomes lose 2. So -2, make sure you have the negative sign. I need the probability of each, and I make sure that my probabilities add up to 1 so that I have the whole distribution. And then I can figure out the expected value. So 1/3 of the time I'm going to win $4. 2/3 of the time I'm going to lose $2. This is exactly like the card one, where the cards, I only had 3 cards. Here I have 6 outcomes on die, but I really split it into 2 outcomes. And this is fair game. The expected value is 0. Sometimes I'm going to win, sometimes I'm going to lose. If I do it a million times, I should expect to have about $0. 0 won, 0 lost. Now another situation. I'm looking at a game, but there's 2 different possible games I could play. Now I generally win about 80% of the time. Which option has a higher expected value? Which option would I pick if I was actually going to take money from my siblings, which I won't do. So for each of these, I can find the expected value. So option 1, I can win $3 and lose $7. I said I win 80% of the time, which means the complement, which is lose, is 20% of the time. And I can find the expected value. So the expected value for option 1 is $1. I should expect to be profitable $1 for every time I play. Now we got to do option 2. So if you want, look back at option 2, what it said, what I win or lose, and then find the expected value for it. Now option 2, I could win $5 or lose $14. So I could lose a lot more than I win in this case. But it actually says my expected value is higher. So I'd win $1.20 approximately every time I played. So both games are good for me, bad for my siblings, because I have a positive expected value. But option 2 is the better option to pick. I win 20 cents more per game. Even though I might lose $14 and I'm only going to win 5, option 2 is slightly better because it's got a higher expected value for me. Now, here's a situation, and this applies a lot more to flights than airport shuttles, but it could also apply to airport shuttles. Sometimes companies overbook because they know that they're not going to have everyone show up. So we can use probability to determine how often are we going to have a problem if too many people show up. And then we can decide, is the policy reasonable or not reasonable? So in this case, the shuttle only has capacity for 6 people. So if 7 people show up, I have a problem, and if 8 people show up, I have a problem. So we're going to use some binomial probability. Now we're going to assume independence, okay, that people aren't coming as families because that would make the probability a lot more complicated. But what's the probability that 7 people show up? Or what's the probability that 8 people show up? So let's use binomial probability. Okay, it says 25% don't show up, which means 75% do show up. So I have 8 people, I want to choose 7 of them to show up. 75% of the time they show up, 25% of the time they don't. Now we got to find the probability that all 8 show up, because that's also a problem. So go ahead, calculate the binomial probability for all 8 out of 8 showing up. Okay, the probability for all 8 showing up is 10%. Okay, 8 people, all 8 show up, 75% chance that each individual shows up 8 times. We want 8 of those. 25% chance we want no one to not show up. So now we can figure out the probability that 7 or 8 people show up by adding these. And we realize that roughly 37% of the time we're going to have a problem. 37% of the time, too many people are going to show up and we can't get everyone to the airport. Therefore, I'd say this policy is a problem. So this company probably shouldn't sell 8 reservations, maybe sell 7. If they sell 7, we'll only have a problem some of the time. And then we'd have to recalculate what's the probability we're going to have a problem if they sell 7 reservations and everyone shows up. So this is how companies use probability to make decisions. Should I oversell? And they have a threshold for how often or what percentage of the time they're willing to deal with issues. I think if they have issues 37% of the time, the company won't be happy. Now, technology also deals with probability all of the time. Companies are willing to sell products and give warranties and replace them as long as they only have to replace a certain amount of products. So here we have tablets and 2 different tablets. Okay, this first one has a high failure rate, but it's a little cheaper to produce and cheaper to replace. The second one, okay, it costs a little bit more to produce and replace, but it's got a much lower failure rate. So I want to know which one's a better product. So I would find the expected value of each case, try it out. And in a moment, we will talk about what the answer looks like and how to justify which model should I sell. So we're going to take a look at these. We'll look at the tab 5000 first. So 95% of the time, nothing's going to fail. I make a net of $50. I get $150. It costs me $100 in parts and labor, whatever else. I make $50. Now, the other 5% of the time, I'm going to lose money because when they fail, I got to replace it. So they give me $150. I paid $100 to produce it, and I lost $130 because I got to replace it. So my profit is negative. I actually lose money here. Now I can do expected value for this. So 95% of the time I make 50, 5% of the time I lose 80. Still expect to make a profit of $43.50 per unit. Now the tab 5001, if you'd like to go do the expected value, by all means do it. If not, I'm just going to show the answer. Okay, 99% of the time I make profit, 1% of the time I lose money. I make less money per unit. Okay, I'm only making $45 per unit, but I could possibly lose more, but I have a much smaller failure rate. And in this case, the expected value is higher. So the new model, if I sell lots of units, I'm expected to have a higher profit per unit. So I would choose the Tab 5001. I would say change the production model, only sell the Tab 5001, make more per unit because of the expected value. And this is how I use probability to make decisions on what is a good thing to do and what might not be so good, what's in my favor and what's not in my favor.